Hey, it's Emma. This topic is wireless networking. We're going to be looking at what this is including, what Wi-Fi is, and how it can be secured, looking at SSIDs along the way. We'll then look at a tricky sounding but important protocol for avoiding data collisions. A wireless network is just one in which the nodes aren't connected by physical wires, but instead use radio waves to communicate. A device needs something called a network interface card, also called a network interface controller, to join a network. And so to join a wireless network, you need a wireless network interface card, more commonly called a wireless network adapter. These are usually internal to your computer, but you can get a USB dongle one if yours doesn't. These connect to a wireless access point. These allow wireless devices to connect to a wired network. Often, these are packaged with a router to create a wireless router, but wireless access points can be individual, but will need to connect to a router to connect to the internet. Wi-Fi is just a name for the wireless technology used in LANs, which is based on agreed international standards. You need an agreed standard in order to maximize the number of compatible devices. Now that Wi-Fi is so popular, very few devices will work wirelessly without using the Wi-Fi standard, as they wouldn't be much use to us. Wi-Fi is less secure to use than a wired medium like Ethernet, because it's easier to intercept radio waves than data traveling through wires. To identify a network, a WLAN has up to a 32-character name called the Service Set Identifier. That is, locally at least, unique. When you connect to the network for the first time, the SSID will be programmed into the network adapter so it remembers it. Unless you live in the middle of nowhere, you'll see other SSIDs of your neighbours or local businesses or mobile networks or whatever. These indicate that they exist and are broadcasting, so are super obvious invitations to a wannabe hacker. You can disable the SSID being broadcast, which will improve security but won't completely hide you. You can also secure Wi-Fi networks by using WPA2, originally just called WPA, which was the older version, which stands for Wi-Fi Protected Access. It works with the wireless adapter and ensures that the network is more secure by using strong encryption. As we'll cover in detail in a few videos' time, each network adapter has a unique MAC address, and you can set up a list of the devices that are allowed to join the network by using their MAC address. A whitelist is a list of things allowed, which is obviously the opposite of a blacklist. It would be impractical to blacklist the billions of devices you don't want on your network. In the previous video, we mentioned the problems that occur when data collision happens. This is a problem with wireless networks too, as radio waves interfere with each other and data gets lost. The CSMA-CA protocol is meant to help avoid these collisions. The acronym stands for Carrier Sense Multiple Access / Collision Avoidance. This is worth learning. It is the kind of one marker examiners like to throw at you. The best way to explain this protocol is to show a flowchart of its operation. When a device wants to transmit data, it is split into frames, which contain a small part of the data and information, like addresses to help route it. Before sending a frame to the wireless access point, the device using this protocol will sense the channel, i.e., determine whether it is clear, in other words, whether it is idle. If it is, then the device will transmit the data and will receive an acknowledgement from the receiving device when the frame arrives. If the acknowledgement doesn't arrive at this point, then the frame will be resent. However, If it had sensed that there was another node is transmitting, i.e. if the channel is busy, then it will avoid collision by waiting for an unspecified period of time. This needs to be random so that they don't keep getting trapped. If a device had to wait for half a second every time, for example, it would be easy to sync up so that the data never gets transmitted, as they are always trying to transmit at the same time. There is a problem with the protocol we just looked at though, which is to do with hidden nodes. This is when two nodes are essentially unaware of each other because their ranges don't overlap. They can both communicate with the wireless access point, but can't tell if the other one is transmitting, so they might sense the channel as clear when it is actually not. You can extend the CSMA-CA protocol by adding request to send and clear to send to it. The idea is the same, except that if the channel is thought to be idle, the device will transmit a request to send, which essentially asks permission of the wireless accept point. If the device gets the all clear back, it is clear to send, then the data can be transmitted. If not, then a hidden node is transmitting and it will have to wait for a random amount of time before trying again. A lot has been covered in this video, so let's take a breather and recap. To connect to a wireless network, you need a wireless network adapter and wireless access point. Wi-Fi is just a wireless network based on specific standards. Compared to wired networks, wireless networks are ordinarily unsecure, but you can improve this by disabling broadcast of the SSID, which is the string we use to identify our wanted network, using the encrypted WPA and whitelisting only the MAC addresses of the devices you want to connect to your network. Finally, we looked at the CSMA-CA protocol, which is meant to avoid data collisions. A device following this protocol will first sense whether the channel is idle, and without RTS, CTS will transmit if it is. If the channel isn't idle, it will wait a random amount of time until sensing again. CSMA-CA with request and clear to send is basically double checking with the access point having been found the channel to be clear. The data can be transmitted when the clear to send message is received. Don't forget that when the receiving device gets the frame, it sends an acknowledgement message back to the original sender.